Continue with our next lecture. Our previous lecture is about moment of inertia, in which we understand what is moment of inertia, what is the use of moment of inertia, how can it help to find out the strength of particular beam, column, or any other structure member. What is the value of centroid? How can we find out the centroid? What is the use of centroidal value, neutral axis value? The total weight of the body is worked on centroid, you know that. So it is also an important term. Okay. Another things are composite section. If we merge different type of shape and size sections in a single diagram, I can say that this is our composite diagram. Like this is a L-shaped diagram, and it is made by two sections, one rectangle, another second rectangle. Two rectangles merge and make a L section. So I can say that it is our composite section. Any other diagram like a triangular mixed with circular section, this is our second diagram. Okay, if two type of shape and size, different shape and size material or diagrams are matched, this will give our composite section. Okay. Further, in this lecture, we will discuss the problems related to moment of inertia. That is, we know that if Ix is higher than Yy, I can say that the beam is more safe in about Xx. Okay, if moment of inertia is higher, that means resistance against bending in X is also higher. Okay, so the value of Iyy is higher. If the value of Iyy is higher, I can say that it is safe in Yy direction also. It is safe in Yy direction than Xx direction. Okay, two values are there. One is for X-axis, another is for Y-axis. Okay, this is the section. Okay, if the neutral axis, like we find out in our previous lecture, the neutral axis lie here. This is our, the Y bar distance is 7.33 centimeter. Okay, and the Xx value is lie 5.34. 5 is this, 0.34 is this. You can see that this is lie here. Okay. 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 The CG is this. I can say that it is lie here. Okay. The value of this is 5.34 centimeter. Okay. So first of all, show your neutral axis of composite section. The neutral axis of composite section is this. Okay, if I need to find out the neutral axis of this particular diagram only, I can say that the neutral axis of this is here and this diagram is here. Okay, it is simply CG of this is, if this is 11, I can say that 11 by 2, comma, this is our 5, in between 5 by 2. Okay, for this it is simply 20 by 2, 10 and 2.5. Okay, this is our neutral axis. This is our CG of this particular diagram and this particular diagram. Okay, if we need to find out the composite section CG, we can find out with these formulas, and the value of this, I can show these values by this. Okay, I'll take the reference axis extreme left and extreme bottom. So I'll give the value from extreme left 5.34. It will shift 5.34 centimeter and it will shift 7.33 centimeter. The final diagram of neutral axis is this. Okay, now I need to find out the value about this Ix and Iyy about this. So first of all, about Xx. When you find the value about Xx, simply make a diagram. Okay, make a diagram again. So the value, what we need to find out, Ixx, make a reference distance. The value is 7.33. Okay, I need to find out the Ixx. How can? Simply, first of all, this section, the moment of inertia of this section, Ig1 is B1 D1 cube by 12. Okay, so B1 is 5, D1 is 20 divided by 12. Okay, this is simply the moment of inertia of this section only. Okay, Second, this is our second section. The moment of inertia of this second section, how can we find out? It is simply 11 into 5 cube divided by 12. So this is our IG2. Okay, IG1, IG2. But these values about the centroid of the reference, the CG of this section is here. The CG of this section is here, but we need to find out the value about here. Okay, this is different from your X and Y. So how can we find the value about these axes? Using parallel axis theorem. That means all these values are find out with the help of parallel axis theorem. IG1 give the value here. I need to find out the value here. How can I find out? We simply add AH bar square. H bar is nothing. It is the distance between neutral axis of standard section with the neutral axis of composite section. Okay, the distance between this is nothing. The half distance is 10. 10 minus the value 7.33. So 10 minus 7.33. This value is our H1 square. Okay. In our next, you know that the neutral axis of this, it is lying 2.5. The value, so I need to find out the value in this axis. The distance of H bar is what? H bar 2. It is 7.33 minus 2.5. So this is our H bar 2. Okay, make it a square. Now solve it and take our answer. Okay, a single diagram make for this. Now to make it clear to the examiner, another diagram for IYY make here. Okay, simply make a diagram. Again, it is our section. Okay, make it properly. In our previous, we find out the IXX value. Now I need to find out the YY. So what we need to show? We need to show only YY axis. That is this. Okay, IYY. We need to find out the IYY. Simply, first we know that this is our CG of this section. The CG line 2.5 centimeter and the CG of this lie here. What is 11 by 2? Okay, the value is 11 by 2. So now the neutral axis of these particular sections are denoted by blue lines. See, this is our neutral axis of this section. This is our neutral axis of this section. Okay, we need to find out the values. If we need to find, just a minute. See, in terms of Y section, I can say that this is our CG. So our neutral axis is here. Okay, here the value of this is 11 by 2 and the value of this is 2.5. Okay, now I need to find the moment of inertia about YY. IYY simply dB cube by 12. Okay, dB cube. Now I see the diagram from here. The value of B is simply 20 and the value of D is 5. So 20 into 5 cube by 12 is the IG. This is our IG1. Okay, for YY axis. Now A1 is simply same as 20 into 5 is A1. H bar. What is H bar? See, if this is 5.33, that is, we find out centroidal 5.33. Now the value is here in CG. We need to find the distance between the reference axis of this standard section and the reference axis of composite section. Okay, so the distance between this is simply, show it with another color. See, this is our H bar 1 value. Okay, so for this section H bar 1 value is simply 5 minus 5.33 minus 2.5. It is 5.33 minus 2.5. Right? Understand? Very easy. You can easily find the distance between standard section, that is simply D by 2, B by 2, with composite section neutral axis. Composite section neutral axis is this. The distance of this we can find out with the centroid 5.33. The value of this simply half, 2.5. So 5.33 minus 2.5 is the value of h1 bar square. Okay. Now come to, this is the solution for the section this only. Okay. I need to find the value of this also, then merge it and we can find out the value of moment of inertia of composite section. Okay. See, this is our second diagram, second section. So the value of this simply I see from here, the value of this is 5. So our B1 is 5 now and 11 is the D now. Okay. So what is the value of 5 into, okay, the value of this, simply multiply it, the value of H2B2, okay, this is our H2, this is our H2 B2, 5 into, multiply it, 5 into 11, that is 16 minus 5 is 11, this value is 11, okay. So 5 into 11 cube by 12 plus A2 is nothing, it is 5 into 11, 55. Now S2 bar square. How can we find out the H2 bar square? See, the neutral axis of this diagram. Neutral axis of this diagram is here. See, this is our neutral axis. And this is the distance, this is 11 by 2, that is 5.55, okay. We need to come here. Okay. The distance between this, I think it is easy to find out. How can we know that this value is 5.33, okay. So we can find out from here also, the value is 10.5. See, this is our 10.5, add it, or you can add it simply, this is our 5, okay, and this is our value 11 by 2, add it, the value is simply 10.5, okay. This value is 10.5. Up, we know that this value is 10.5, okay. Now minus it. See, the distance between the neutral axis of this and this value we need to find out. This value is nothing, it is 10.5 minus 5.34. Minus 5.34, you can find out the 5.34 value from, this is our centroidal axis value, this is this one, 5.33, okay, and 10.5 is the total value what we need to now minus it and find the value of H2, okay. So all the questions, solve it and find the answer. All the questions simply depend on the parallel axis theorem, and parallel axis theorem is nothing. See, we need to find out the value about this AB. If I need to find out the moment of inertia about AB, okay, what we need to do, I simply find the centroid of this diagram. If the value of this diagram is x bar y bar, okay, now I just need to find out the distance between the neutral axis of this particular diagram, that is like composite section CG is this. So we need to first find out the centroid of this, okay, and find out the IG about this section, okay. Now just add it with AH bar square by 2. A is nothing, it is simply area of this section. H bar, see, the value of H bar is tough to find for the student, so understand it properly. It is nothing, it is the distance of CG from the reference axis. Okay. In all question you do this, like this is our standard IG, like this is our IG, okay. The distance that is for composite section we need to find out on this axis. I'll just find the distance between these, same as we need to find out the distance between these, okay. So standard, the value of neutral axis with the distance between neutral axis and the reference axis, that is AB, where we need to find out the moment of inertia. I'll find the distance, put it in formula and find the values of all questions, okay. Now See another question based on the same technique, same things, just the shape is different, that is T section. Again we add two sections, one is first rectangle, another is second rectangle. Like you can see that this is our first rectangle, okay, and this is our second rectangle. The distance of this 3 plus 6 plus 3 is 12, okay, this is 3. So our A1 is what? 12 into 3. A2 is what? The 12 value is this, and this is our 6, 12 into 6, okay. If I need to find out the x1, how can I find out the x1? First of all, I need to make some assumed axis. Like I assume that this is my x, this is my x6, neutral axis lie here, extreme bottom, and in extreme left it lie. If it will not lie here, then it will give some value. From that value, you can shift it to higher, okay. Find the values like x1. x1 is what? See, for the x, the CG is this. So our x1 is nothing. It is simply the half of this. I can find out the values, okay. See, in this section, okay, y1. See the value of this. This value you can find out like A1. A1 is this. A1 total value is 12. 12 by 2. Okay, divide कर लें आप. Same as for x2 करके देखें. See, x2. How can find out the x2? The CG of this. Okay. In some questions, like this question, I want to tell you one more thing. What is this? Like, if see the CG of this section, just a minute. The CG of this section, see, this is our first section, this is our second section, okay. If I need to find out the CG of this, I know that all the CGs are lie in centers. If I find the center of this, it will lie here. If I find the center of this, it will lie here, okay. For first, it will lie here. For second, it will lie here, okay. If these are the centers, now I'll make a line. I cross a line, and I see that it will pass from both the sections, okay. It will pass from both the sections. I can say that the CG, the x bar, we don't need to find out in this question, because it is simply, it is half. Like if it is 3 plus 6 plus 3 is 12, it is lie in 6 meter, okay. It will lie in center. Center, where is center? Center simply, it is in 6 centimeter. The center lie, center here, the center here, the line is matching. So I can say that it is simply 6 centimeter. So in this questions, like this type of question, like I'll make another diagram like I section, okay. The symmetrical I section. As if a symmetrical I section means, what is symmetrical? Symmetrical means the area, this area is simply equal to this area. That means it is symmetrical about x-axis. If this area is equal to this area, I can say that it is symmetrical about y-axis, okay. That means left portion equal to right portion, that means it is symmetrical about y-axis. If bottom portion is equal to top portion, I can say that it is symmetrical about x-axis, okay. So if I section, I'll make a symmetrical section. I simply say that, see, it is a symmetrical section. If it is a symmetrical section, see, okay, symmetrical section. The y, the centroid of this lie here, the centroid of this lie here, the centroid of this 3. If this is a first section, it is second section, it is third section, okay. The centroid of all these are lie in between, and this line pass through all sections. I can say that the value of x bar is, don't need to find here, because I know that it is lie in mid, okay. Same as for it is symmetrical to top and bottom also. I can say that this is also line in middle. Okay, so at that time it is lie in middle, approximately. So in these questions, if the question is very lengthy, at that time you don't need to find the centroids, because some questions as centroid are given already. Okay, we don't need to find on that particular section. Okay, in this question, you know this, you see that in this question x bar is not founded. Okay, IYY also not founded, because it is well known that it is lie in mid. So y x bar is simply in mid, so it will give the simple, like I need to find out IXX here. Okay, sorry, IYY here. If I need to find out the IYY here, I know that this section is symmetrical to y axis. Okay, so I can say that it is simply IG1 plus IG2. All I find the center about this, I find the moment of inertia about this, I find the moment of inertia about this, and this will lie in same line. So I can say that I don't need to find out it. Okay, I simply find the values of this and find the value, and I know that this value surely come to this, come less to this value. Okay, so I don't need to find out it. If you want to find out, you just add moment of inertia of IG1 plus IG2, like D1 B1 cube by 12 plus D2 B2 cube by 12. In this question, I'm not using parallel axis theorem. Why? Because here the CGs are lie in same line. So there is no distance. What we need to find out by H bar is nothing. H bar is nothing. It is merge. So reference line merge with neutral axis. Okay. So at that time we don't need to find the moment of inertia about any reference line. The centroidal line moment of inertia is similar to the reference line area. So I just added IG1 plus IG2. The value of IYY is given by simple. So in this question, I'm not finding the value of IYY. I'll just find the value of IXX. Why we need to find out the value of XX? See, the y, the x value, the y distance, see, the centroid of this line is lie in y. It is lie some here. The centroid lies some here. It will lie here. I can find out the values. How can I know that? Because if I cut it, see, if I cut it from here, okay, maybe the top is equal to the bottom. Okay, but if I cut it from here, I know that this value is less than this value. Okay, because the area, upper area is higher than bottom area. So at that time, the neutral axis compulsorily shift to some distance, that is like some distance. Okay, so here I understand this, it will not lie in CG. The CG of this line, the CG of this line, the x-axis of this line and this line is not lie in similar lines. See, the centroidal axis of this is this. Okay, the centroidal of axis of 2 is this, and the reference centroidal axis is this, right? It will not lie in similar place. So I can say that we need to find out the moment of inertia about this reference line. And what we need to do, we need to use parallel axis theorem for this question to find out xx. Okay, to find out xx, because centroidal neutral centroidal axis is not lie with the reference axis. Yeah, or you can say that centroidal axis of the standard section is not lie with composite section. So at that time we need to solve it as previous question. Okay, in second case, if I need to find out IXX, I need to do the process similar like previous question, but when I need to find out the IYY, what it is, easily I can use the centroidal values and find the values, because I think you understand the centroidal axis of C, like the lines are different for each. First centroidal axis line different place, second centroidal axis lie in different place, so composite will lie in different place. But when we discuss about why the centroidal axis of this is lie here. The centroidal axis of second is lie here. The composite section axis is also lie here. So we don't need the neutral axis is not shifted. So I can say that it is simply, I just find out Ig1 plus Ig2. I can do it in the reference of y axis. Okay. I hope you understand why in this question Iyy is not finded or x bar value is not finding, because it is lie in similar place. Okay. So you have to understand the concept of symmetry, and sometime question is very small but the diagram is higher and it is symmetrical diagram and you are not able to understand that. We just need to solve it by half portion, another portion already known. Okay. So understand the use of symmetry. Okay, this is the different thing that that is in this question. Now just do A1, A2, need to find Y1. Okay, now we need to find Y1. How can we? Okay, simply you can find out the Y1 in same way, like you make a diagram, another diagram. Okay, just make another diagram. We need to find out the IXX. IXX is here, lie here. Okay, neutral, maybe it will lie here. Okay, or we need to find out the neutral axis. So at that time, the extreme bottom, take a extreme bottom and make all these values extreme bottom values, like for this one, for one section. If I'll take the value, I think in this question it will take from top. Okay, if that I'll take the value from, I'll take the value from bottom. See, it is our reference axis AB. So at that time, the centroidal axis lie here. It is 3 by 2. This value is 3 by 2. Add it by 12 and you will get Y1. Same as Y2. How can we find out the Y2? The value of this section. It is simply half of this. 12 by 2. It is 6. Okay. Multiply it. Find the value of 8.5. That means it will lie in 8.5 centimeter from the bottom. So the value, this value is simply 8.5 centimeter. Okay, this is our neutral axis distance for y. Okay, now use directly IXX, B1, H1, you know that, A1, you know that. Similar, the distance between the first axis and reference axis. Okay, reference axis आपकी neutral axis, this one is neutral axis. Okay, another composite section neutral axis this, so H bar is this. Simply we can find out it by subtracting and find the value of this. Okay, Y1 minus Y bar. Put all these values and find the answer. It is 2241 centimeter to the power 4. Okay, all questions related to moment of inertia are like this. If moment of inertia value is higher, that means it have high resistance to bending. Same question for hollow question. Simply we know that first rectangle is subtracted by another rectangle, so it will make a hollow section. So in questions just use minus, nothing else. A similar question. Okay, in I section there's no symmetry. There's no symmetry. The Y section you can see that the centroid of this, centroid of this, centroid of this is line same. So we don't need to find x bar in this question. We just find y bar and use the value. Okay, because we know that the top is not similar to the bottom, so we need to find out the y bar. Okay, find the value of IXX. Similarly for T section. Okay, similar. This is also a rectangular section question. This is our simple rectangle. In this we just use parallel axis theorem. We know the value from here, and we need to find out the value in OM and ON. Very simple question. Second question is similarly, use the formula for triangular section. That is first one. Second is semicircle. Second is circle. Okay. 1, 2, 3 you can take according to you. In this question, this is maybe assume as 1, this is 2, this is 3. So assume it and solve it. You just find the formula for circle, find the formula for semicircle and use all these values and find. Okay, same as in this, for first one is rectangle, another is for circle. All questions are similar, like if something is subtracted, like a rectangle, a circle cut between rectangle, that means we need to use formula in subtraction form. Okay. So these are the questions related to moment of inertia. If you have any query, give in comment. I will solve. Okay. Thank you so much.